said that. Okay, so we're going to do a review. We're going to do a few problems for the test coming up, and so a couple of the ones we're gonna write. The first one is just going to be like the domain. So the domain is going to be of the rational function right in the interval notation. Remember, what is the problem? What do we have to look for what are restrictions on our domain? If you remember, f of x can never be a number over 0, all right, because at that point it's undefined. So in that case, you always look at your denominator, and you're going to find the places in your denominator that are undefined. So in this case, x is undefined at when x is equal to, if I set the first factor equal to 0, I get what? I set x, yeah, I'm going to get 2 because I'm going to set x minus 2 is equal to 0, and I'm also going to set x plus 6 equal to 0. So it's undefined at 2 and, yep. So there's my key parts on that. And that means that what happens, it'll be a value for every other part in my graph. And so since I'm just doing my domain, I need to make sure I write it so that I eliminate these values here. So I start off, if we remember, we kind of did a number line. We went from -6 to 2. And in this case, I'm going to let all the points that are less than -6 be a part of my function or domain. So I'm starting off with -infinity to -6. In this case, it cannot equal -6, so I'm going to have to put a parentheses. But then I can have all of the points in between here, so I'm going to go union with -6 to 2. And then I can have all the points that are going to represent in this unions or section. So it's going to be from 2 to infinity. And so that would be my domain. On the next one, on the vertical asymptote, this one's going to be it has a extra trick because we have to identify the holes. So in this case, I would start always, remember, factor. How does x squared minus 25 factor? Perfect. That's a difference of 2 squares. And notice that I have a factor of x minus 5 on the top, and I also have 1 on the bottom. That means I can cancel those out. So I'm left with 1 over x plus 5. Well, what's left is going to tell me my asymptotes. My asymptote is going to be where x plus 5 is equal to 0, and that means I'm going to move it over, so x is going to equal -5. Now, they didn't ask us to graph it, but think about it. If I have a graph here, and I'm going to say at -5, so I'm going to say over here this is a -5, I have a vertical asymptote. That means all the points are going to get really close to it, but never touch it. But when I also eliminate one of my values, because on the bottom here, it still couldn't be -5 or +5, because when I have the equation x, I'm going to put holes. I'm going to have a hole where x minus 5 was canceled out, and so that means where that is equal to 0, and it's going to be at x equals 5. And so I have a hole at 5, and the graph kind of will look like this, where I get to about the value of 5, and I have just a hole in my graph. And then it'll look like this. But again, they didn't ask us that, but they did go ahead and say, find the vertical asymptotes. And so the vertical asymptote is going to be right here at x equals -5. And if any value of x corresponding to holes, and the hole will be right here. That makes sense? Now there's 3 things we look at on the horizontal asymptote to find horizontal, because we talked about vertical asymptotes. This is the vertical asymptote. Horizontal asymptote, we had 3 rules in our notes. We had 1, 2, 3. Okay. The first one was if, and they wrote it out as n and m. Okay. So and the but I'm going to go ahead and write it the same as the degree. If the degree, okay, which in this case is going to be smaller on the top than the bottom, then you always have an asymptote at y equals 0. And I'm going to leave a little more room, too. So we'll go ahead and do all 3 rules and then we'll solve it. So number 2, gosh, I was right, number 3. Number 2 rule was that if they're exactly the same, if the degrees, now if I say the degrees, am I making sense?
Yeah.
Okay. Are the same, then your asymptote is be the leading coefficient over the leading coefficient. So the leading coefficient of my top over the leading coefficient of my bottom. And the third one, if it's the opposite, so if the degree is more on the top, then you have a slant. And we're not going to do that in this section, so I took that section off. So really you only have to focus on the first 2. So let's take the value of A. A is going to equal, you have 21x squared over 7x squared plus 3. Which rule would that one be?
The second one?
Yep, the same, because they're both squared. They're the highest power I have, so this is a degree 2 and this is a degree 2. So what I do is I'm just going to go ahead and eliminate anything behind it. It's going to be 21x squared over 7x squared, and that's why they cancel out. So I have 21 over 7, and those are my leading coefficient on the top over my leading coefficient on the bottom. And I simplify. So 7 goes into 21 3 times. Now remember, it's a horizontal asymptote. Okay, so in this case, when we had the vertical asymptote, it was always, in this case, x equals -5. This one will have to be y equals then 3. And so my graph is going to approach those locations. Okay, so then look at the second one, B. You have 21x over 7x squared plus 3. What do you notice? Which rule will you apply? The first one. And so on this one, because this is smaller on the bottom, you all just know that it is going to be y equals 0. As you can't see it. So questions on that one? All right. So then I give you one, okay, that has everything in it. Okay, so we're going to start off with just symmetry. I think on the test I changed it from my key. I'm going to need a little more room. We're going to start off with just determining symmetry. To determine symmetry, remember we put in f of -x in. And then we compare it. So in the first one, you're going to have 6 times -x. You'll have then -x expression squared minus 4. And this is going to then, this sign will not change because it's x to the first power, so it's a -6x over, but when I have -x squared, that one changes, so it's x squared minus 4. Because one of them changed and one of them didn't, there is no symmetry. Remember before, if they all were the same, like no change happened and it was exactly the same function that you started off with, that would be symmetric about the y-axis, because it's going to look the same from left to right. If everything changes, then it's symmetric about the origin. Okay, so the next one we're going to go is just B, find the y-intercept. Now B on that, when we have a y-intercept, that means that the value of x is going to equal 0. And so what we want to do is we want to actually just set the top number, or the numerator, equal to 0. So if x is equal to 0, then we're going to substitute 0 into my equation. Sorry, I'm looking for f of 0. That means I'm going to go 6 times 0 over 0 minus 4. Well, 6 times 0 is just going to be 0 over negative 4. That means I'm going to get 0. So one of my points is going to be 0, 0. And that's going to be both my x-axis happens to be, or x-intercepts and a y-intercept, since they can become 0, 0. So I'm going to go and plot that point. The same thing on C. The x-intercept, y equals 0. In this case, I'm going to set the whole equation equals 0, which is still going to be, then it's going to be just 0, 0. We found that from the first one. Then let's go ahead and do CD. We're going to do the vertical asymptotes. Now I want to go ahead and I need to look at the denominator. What do you recognize about the denominator? Does it factor?
Yeah.
Yep. So let's factor it. How does it factor? Yeah. Did you say plus what? 4.
No,
Or 2. 2. Yeah, you go x minus 2. And that means that my vertical asymptote will be then at x is equal to 2 and x equals negative 2. So I'm going to go ahead and plot those also. So I'm going to go ahead and put vertical asymptotes on both of those. And then DE, I'm going to find out the horizontal asymptotes. And this is what's causing my no symmetry. So it's going to, it'll make sense, I think, when I get it done. So when I look right here at the first one, I've got 6x over x squared. So I'm looking at just my leading coefficients. What about my degrees? So you have 6x over x squared. Those are going to be determining my degrees. The degree on the top is less than the degree on the bottom, so that means I know my vertical asymptote's at, or horizontal asymptote. Yes, horizontal asymptote is going to be y equals 0. So I'm going to go ahead and plot that. And then F. Find any additional points. Now what they're talking about is they're looking at regions, okay? And so if I kind of imagine, I've got kind of a section over here, I've got one down here. I know that they're not going to probably be on both because my graph is going to actually go to one or the other. But I need to find out what's happening between, like when x is greater than 2, is it positive or is it going to be negative? And that's going to tell me that my graph is going to approach my 2 asymptotes at that point. So I want to pick a point, like say I want to say x equals say 4. Okay, if I pick and again I don't have to pick 4. I could pick 6, 8, or whatever. But then I'm just really not worrying about, because my horizontal asymptote is 0. I'm really not worrying about the actual number. I just want to know what's positive. But on this one, if I put in 4 for this, I'd have 6 times 4. Okay, so I'm going to have a positive number on the top. I'm also going to have then, I have 4 plus 2. And 4 plus 2 is going to give me a positive number. And if I have 4 minus 2, I still have a positive number. That tells me that my graph is going to be positive, and that's really all I want to know. I don't have to have specific values here. Okay? Now I need to find out what happens also in my next sections here, because I know I have a 0 here, so I'm thinking what's going to happen, it's going to be like, since there's no symmetry, it's either going to be a U-shaped here or it's going to be a U-shaped up here. And so I need to find out then also what's going to happen between in this value. So I could pick like when x is equal to 1, and I'm going to do the same thing. Again, I'm trying to find out if it's positive or negative. So on the top, I'm going to go 6 times 1. Well, that's going to be positive. On the bottom, I'm going to have 1 plus 2, which is positive. But then I'm going to have 1 minus 2, and that's going to be negative. So that tells me right there that this value right here, when x is 1, it's also going to be negative. And guess what? It works the same way if it's going to be a negative 1 as well. I'm still going to be negative. So I'm going to go ahead and plot my point. I know that my graph is going to get close to that. And then I want to check one more region over here. Let's say it was -4. So again, I'm worrying about like x is equal to -4. I'm going to say on the top, I'm going to have then a negative number. On the bottom, I'm going to have -4 plus 2. That's going to be negative. If I have then a -4 minus 2, that's also going to be negative. And the three negatives together will result in negative. That means it's going to be down here on the bottom. And it's going to approach. And that's all I really want. You don't have to get more specific. Once you get into more math, you could find out kind of where these points actually are. But this is the rough estimate of my graph. That's what I'm asking for. Make sense? Perfect. The next one, solve the rational inequality and graph the solution set on a real number line and express the solution set in interval notation. So in this case, what I want to find out is where x is equal to 0, because I'm comparing this to 0. So I always want to set my inequality equal to 0, and I'm going to put it on a number line. And then I'm also going to find out where is x undefined. Okay, so if I set the top equal to 0, I'm going to set 8 minus 2x is equal to 0. That's going to tell me where it actually is 0. So in this case, I'm going to move my 8 over, so I'd go -2x is equal to -8. X then is going to have to equal. So when x is equal to 4, so let's go ahead and just get some points here. There's 0. I'm going to put 4 here. Then I'm also going to find out where it's undefined. So it's undefined when 5x plus 2 is equal to 0. So I'm going to move my 2 to the other side. So 5x is equal to a -2. X is going to equal -2/5 as I write 5/2. Okay, -2/5, which is right here. So really, those are my 2 points that I'm most concerned with and what's going on. So I'm going to check my regions, and I'm going to check this region, I'm going to check the one in between, and I'm going to check here. And so on this case, I'm going to pick something to the left of -2/5. So let's just say -1. And again, I'm not worrying about what the actual value is, but if I have 8 minus 2 times 1, 8 minus 2 is going to give me a positive number. On the bottom, if I go 8 1 times 1 plus, I also get a positive number. And so this is going to tell me all of these points, no matter what I pick, is going to be positive. So far, so good?
Yeah.
Now, on the second one, I've got, if I let 0 be the case here, so if I go 0 on this on the top, I also am going to have, it's going to be positive because I go 8, I'm just going to have 8 over 2, and 8 over 2 is also positive, so I have a positive over a positive. So this is going to be positive. And then I'm going to check between what happens after 4. So on the top, I'm going to have, if I think about a point like 5, 8 minus 2 times 5 is going to give me a negative number on the top. And I'm going to have a positive number on the bottom. So in this case, that will result in a negative number. So then I'm going to only look for places where it's going to be less than or equal to 0, and it's only going to be right here. So how do I write that part in interval notation? I'm going to start with the lowest. Yeah, start in this way because the negative infinity would be over here, and you're right. If I had it, in fact, we'll on this one. Let's go ahead and just do. It starts my smallest value to the left is just going to be 4 to infinity, and then what's going to happen then it includes 4. So I need to make sure I put a bracket and a parentheses. Now, if this problem had been greater than, then you would also want to exclude your point. So it would be this section, so a negative infinity to -2/5, 2/5 to 4, and then it would be the union of those two with the parentheses because it cannot equal 2/5 because that's made it undefined. Okay? And the number 7 was our varies jointly. And what I'm going to let you work this one and then double check it. So just give me the formula for varies jointly was y equals as if it's jointly, it's going to be the same as x increases, y also increases. So it's going to be k times x. It's the same as that slope. What's the difference for this one is a combination. This one's going to be varies directly, indirectly, inversely. Let's set this one up. It says one's intelligent quotient, or IQ, varies directly with the person's mental age and inversely with the person's chronicle age. This is the one that I don't want to use K, and I don't want to use A because I've got ages. So let's go ahead and use I for the IQ. And then I'm also going to go for the person's mental age. I'm going to use M. And then the chronological age, I'm going to use C. But you can use whatever you want. But let's set up the formula. So if I start off with, I'm going to go I is going to vary directly with a person's mental age, so I know I'm going to have a K. Mental age is going to be on what part? The top or the bottom? Did you say top? Top. And inversely with the chronicle age. So that's going to have to be then, since it's inversely, it'll be on the bottom. And then I'm going to put my value behind K. So do you want to finish this one, or do you think you want to try it? You want to try it on your own? Yes, we can. So if a person's mental age is going to be 23, so here's M is going to equal 23. Chronicle age, so C is going to equal 35. And then IQ is going to be 138. We're going to substitute those values in. So I'm going to have 138 for I equals K times my mental age, which is 23, all over then 35. And to finish this, I'm going to grab my calculator, because what will you multiply together first? Yes, so 35 times 138 gives, oops, I had something crazy in my calculator. 35 times 138. How about 4,830 is equal to 23K? And then the next step would be? Good. 23 divided by 23. So I have 4,830 divided by 23, and so my K equals 210. So then my next part of my statement, I'm still going to use my formula, but now I can change my K because the K is going to be a constant. So I'll have I equals then 210 times M all over C. So what is the chronicle age? So in other words, we're looking for C. If the person's mental age is 20 and the IQ of 140. So we put those values in, so I'm going to have 140 is equal to 210 times the mental age of 20, all divided by C. So I would suggest multiplying both sides by C so that you have it on there. So I have 140 C is equal to 210. I'm going to go ahead and tell it. So 210 times 20 is going to be 4,200. And then C, the chronicle age, would be then 4,200 divided by the 140, or 30. And I'll put years. Okay, any questions on that one? Okay, I'm going to let you work and see, and again, you have the key in your on your lesson plans.